First slide talks about why we should back up the data. I don't think I need to go in detail. The importance of backing up any data, not just database data, is so crucial. At one point of the time we experienced this issue, right? This kind of a situation. Yeah, I should have had a backup, right? So just at a high level of some of the common problems we might see from a database point of view is a power or hardware failure. What if some application corrupts some data and we had to roll back? A media failure like a disk drive becoming unusable, and a major disaster. Now, what is the basic concept of backup and recovery? This is a slide I was referring. Why we should back up our data, just to avoid this kind of a situation. What is the basic concept of backup and recovery in DB2? Again, this is nothing specific to DB2. This diagram is applicable for any database. For example, at time t1, I have a backup, whether it is a full or incremental backup of a database. I have a t1 backup. At time t2, the system crashed. The disaster strikes. This is a disaster. This is not just someone pulling out the power cable and putting it back. I'm talking about a complete disaster. For example, losing a disk drive, even losing the other disks which has the RAID as well, right? Or someone dropping a data file, that kind of a disaster. So at time t3, what do? We have a time t1 full some kind of a backup. From time t1 to time t2, the database continues the transactions, and these transactions are recorded in log files. If you go back to Oracle, we call it as a redo, and some of the other databases we call it as a transactional logs. It's as equivalent as applying the full backup here, then on top of it restoring the full backup here, on top of it applying these transactional logs. It's the same process at a high level as any other database, no difference. But the concept is, how do I take a full backup here or an incremental backup, that is a physical backup, and how do I take a logical backup, right? So physical and logical is what we are going to look at today. Let's start with understanding this logical concept, the transactional logs or redo logs. Right. DB2 database logging. It keeps track of changes made to database objects and data. Right. During the recovery process, DB2 examines these logs and decides which changes to redo and which changes to undo. Now, since we have used the word here undo, let me tell you, if you are from Oracle, there is nothing called undo table space here. Right. There is no separate undo table space which keeps track of prior image and after image. Right. All kept as part of transactional logs only. Of course, database logging is a key element of any high availability strategy. We can store these transactional logs or redo logs or the log information in files or on devices, raw devices when I say devices. Now look at this diagram here. Let's say someone is trying to update. For example, if I am trying to change one of the employees' salaries from 10,000 to 12,000, right? So the update transaction is going to happen within the DB2 memory. Right? So what is going to happen? So let me put it in a notepad here. Again, this is the same stuff as any other database. Like you have a memory, you have disks at the bottom, which have pretty much have the containers or data files, right? So the basic IO. So the basic IO, when someone reads something from physical the storage to memory, is page. Data comes in the form of pages, right? So if someone ran this command, for example, update employee salary table, set employee salary to 12,000, where employee ID, for example, is 549. This salary, let's say, is using 10 pages to store the data, where each page is 4 KB, right? Or let me say that this salary is using one extent, because the storage happens in the form of extent. Storage allocation happens in the form of extent. What is an extent? Extent is nothing but 32 pages. For example, whenever I create a table called salary, an extent is allocated for me, right? 32 pages. Once I fill up all the 32 pages, the next extent is allocated for me. So when I say 32 pages, what is one page size? One extent is allocated. One extent is nothing but 32 pages. What is one page size? The default is 4 KB. That means in a one page I can store 4 into 1024 bytes, which is nothing but 4096 bytes. Okay. One page can hold these many bytes. Now what is the row size here? When I'm storing a record in salary, what is the size it occupies? That depends upon the data types. Employee ID is 4 bytes integer. When I say varchar 20, assume that maximum, which is 20 bytes. Let me put it as a 16 or whatever that is. So total sum is 4 bytes plus 20 bytes. 24 bytes is what I need to store one record. For storing one record in employee salary, that means if I do an insert statement, I think I'm missing one more column here. For example, salary. And let's assume that decimal needs 4 bytes. So plus 4, which is 28 bytes. Okay. So one record, something like this, needs 28 bytes. That means how many records I can store in one page? Question is how many records I can store in one page. The page is something you can think it of as the notebook that our kid takes or uses for writing something. So notebook, in each page you can write, you have n number of rules, right? So the same thing. So if one record needs 28 bytes, how many records I can store it in one page? So 4096 by 28 is approximately 146 rows. So why I'm explaining all this is to help you understand how many rows I can store it in one extent. So if one page is holding 146, one extent is holding 146 multiplied by 32, somewhere around 4700 rows. Whenever you create a table, an extent is allocated for you. The default extent size is 32 pages, right? If your row size is 28 bytes, you can store approximately 4700 rows in that extent. But the bottom line here is the data transfer between hard disk, that is physical storage, to memory is always in the form of pages, not extents, right? So the moment someone fired this update statement, let's say if OSHA fired this update statement, what system does is it tries to look at which page has this record associated with 549. Which page has record associated with 549, right? How many pages I have? 32 pages. Out of 32, it can be, let's assume it is part of page number 20. So out of the 146 records or rows this page has, my salary information is there. So this is the important point. You cannot read just one row from hard disk to memory. You cannot. That's how the system's built. It's the same thing in any database, right? Probably Oracle calls it as a block. You have to read entire page. That means the entire page that is holding my record, that is the rest of 146 rows also, will read it into memory. So we haven't spoken on the memory architecture yet, but you keep some memory aside for the major operations such as update, insert, select. So you read the page, which page that is, we assume that page number 20 into memory, right? Sometimes the pages on a disk are compressed. So you read it into memory and you uncompress it, right? Whatever that is, the bottom line is the basic IO is page and you read the entire page that is actually holding the records of my interest, right? Now here you start updating. One of the rows, row 1, this page is having row 2 like this. So probably this is my row 549, whatever that is. So right, I'll just update this record. Now the agent is the guy that takes care of it. We'll see more on this in memory architecture. Now agent will update this row. The moment this happens, right, the change details like what is the previous version of it and what is the modified value will be immediately written into transactional logs. This is done by log reader. There is a separate background process which takes care of it. Its job is only to see if anything is getting changed in memory. Now coming back to this presentation slide, that's exactly where we are at. Now, yeah, sorry. This is not written into transactional logs directly. Whenever any change happens, there is something at a memory called log buffer. The moment you hear a word in DB2 called buffer, it is memory. It can be any buffer, or log buffer, or XYZ buffer, or any buffer pool. Buffer means memory, right? So this information is written in log buffer. Each log buffer has a certain size, right? So the moment you start writing into log buffer, it's not just you, right? Vasu might be working simultaneously, Chandra might be working simultaneously, right? All that information is written in this log buffer. The moment this log buffer is full or a transaction commits, those are the two scenarios. It immediately flushes the information out of this log buffer onto transactional logs on disk. Again, I don't expect this to be different than any other databases, but if you're comfortable with at least one transactional logs, it's the same scenario, or redo logs. That's exactly same explained here through a diagram. Whenever you are trying to do an update transaction, the respective page is read from disk to memory. Now the respective update operation takes place. The changed information is written into log buffer, right? This log buffer has a specific size. I'll show you in the next slides, right? Once this log buffer is full or a transaction commits, the information is written into logs which exist on a disk so that they will be preserved for some time, which we call it as active and online logs. From here, you'll move those logs to an offline archive location for longer storage time. Before I move on, let me stop here and take questions if anything that I confused so far. Okay, if no questions, let's move on. So the log files I talk about disk have various states. Those have various states based upon the time, pretty much, the information they store, right? You can think of these log files as a file 1, file 2, file 3, the some kind of a files you just create, simple files, right? These log files are stored in a specific directory. Within the directory, let's say I have 10 log files to start with. So the log file can be an active log. When I say log is active, when it contains at least one transaction that has not been committed or rolled back, right? I can have more than one log file. So this is how I put it. Log files, for example, a specific directory. I have log 1. So here let's assume that instead of log 1 s1 s2.log, s3.log, s4.log, s5.log. Let's say I have these 5 logs when my database operation is starting. So it starts writing the changes here. Log buffer flushes changes here. So this log file size might be, let's assume that it's a 2 MB. My log buffer size might be maybe 50 KB. Right? So the log buffer keep flushing the data into s1.log till till it writes 2 MB of data here. Once this 2 MB is done, it will go to the next log file. So it's pretty much like the one best example is I live in an apartment. We have a watchman downstairs. Watchman has a logbook. Whoever are the people coming in has to sign in, write their name, provide the ID card and sign in time and out time. That's the pretty much the log, right? Once the book that he is using is full, what happens? He will be given a next book, next logbook. The same here, right? So the moment I flush something from a log buffer into a log, once this is full, it goes to the second book, right? Now these log files, we just put it some kind of information, such as if any log file has a one open transaction, then we call it as an active log. Pretty much this active log is always the log that is current, but sometimes if I have a long transaction of a million rows update, then S1 can be active and S2 can be active and S3 can be active. That's a extreme scenario. If a log contains at least one transaction that has not been committed or rolled back, then it is active log. After this, we have something called online archive logs and offline archive logs. Online archive logs contain committed and externalized transactions in the active log directory, right? So rest of all the files that exist in this directory called online archive logs, right? So once I move from this s1.log to s2.log, you move to next log file. This is current. This becomes now current, right? That means these are full, right? So you have another directory called archive directory. For example, that can be part of other directory. Now you move these s1.log, s2.log to this location. Now they are gone from here. Now you will allocate S6, S7, S8, right? So two different directories. Now the source for these directories is log buffer. Log buffer writes into these active or online. Log buffer writes into active or online. From active or online, it will go to archive location. Same, right? Same life cycle of the books. We give it to my watchman. We buy a brand new book, we'll give it to him. Once the book is full, we'll give him the second book. That's pretty much the second log. Once that log is also full, we'll give the third. What do we do the old ones? For record's sake, we'll store it in archives. That's a separate place. Same here, right? But these are holding the two different directories, and we'll see that information. So that's what we are showing with the arrow here. That's a separate location. Now these logs, I extended in a forward direction here. So once S4 is full, it will move to the next log file, S5. After S5, it will go to S6, right? S6 becomes current. Now what I have told here is once these are done, I said that these will be moved to archive location. These will move to archive location, and a new log files will be allocated, right? But it may not be true always. So whether I move the field log files to archive directory or not depends upon my log mode. I can have two different types of loggings. One is circular logging, another one is archive logging. So the scenario I spoke here is called archive logging scenario, where the logs will move in a forward direction, only in one direction, unidirectional. But this is a preferred way you do it a production for DB2. But there are some scenarios, sometimes on a non-production environment, you say my log file says 5, that means 5 log files will be allocated for you. Right, your operation starts here, log buffer starts writing here. So this is a scenario of circular logging. This is not a preferred scenario, I say. I repeat, it's not a preferred scenario for production. So it starts at S1, after that S2, S3, S4 and S5, then it will come back to S1. It's like you have a magic pen, right? Magic something, you can erase whatever it's written on this notebook. That means you cannot go back if you need beyond this S1. It's a circular, that's what it says here. It starts with 1, then you write it into second log, third log, fourth log, and after 4 you'll overwrite 1. Right. So we call these logs, whatever is a log files parameter, as a primary log files. Now don't get confused, there is something also called secondary log file. I'll explain in a bit. But before that, let's also look at archive logs one more time. I have already explained archive logs. Instead of you overwriting like the notebooks, you will preserve those notebooks in some other location, archives, for later use. Right. Think of a library, right? You sign before you enter the library. The records are kept for a longer time. The notebooks, people in and out times. Right. So now the important thing is we need to answer ourselves the question, the various questions that what happened here. Okay. We need to ourselves answer some questions like, what is log buffer size? How many transactional logs allocated by default? What is each transactional log size? Location of these transactional logs. Location of archive log. How do I find out my logging type of a database? Because we have circular and archive. So these are the questions that I will answer in the next few slides. Before I go there, before we move on to the next slide, any questions so far?
Yeah, Ravi, this is Vasu.
Yes, sir.
So in this, is there a specific reason why we need to have so many S1, S2, S3 type of logs? If you look at SQL Server transaction logs, which is in the database log, we'll have only one. It is, we just allocate as big as possible, and it is just a sequential. When it is almost getting full, it will go to the first location of the LSN path, whatever the dirty pages are being cleaned out, it just goes and uses it instead of going back to the new log. Is there anything that is specific like Oracle that we need to have such sequence numbers like 1, 2, 3, 4?
Yeah, good question. Let me think on it. So we generally say log switches.
And one more thing, see in Oracle, this is the old practice that we used to do. Now I'm not using much, but whenever we are doing some important task, we do first a log switch and then we'll start. So when it do the log switch, it will have a clean log. That's what we used to do. Is there anything that we need to do for the DB2 also when we do such things?
No, not really. Even that practice in Oracle is gone long time back, right? So no, not really. So just a safer side, we do a log switch so that when in worst case and we have to recover, it's just pretty straightforward giving that log number from where to recover.
Yeah.
To answer your question on having a bigger log files, yes, you can do it. You can still give it a bigger log file, right? So what we are talking about here is I hold on a second. So it's the question of how safer your log file location is here. Okay. What we are saying is we are saying that log buffer, which may be like 50 KB, I write it into a logs. So I would just say that s1.log. I just say it here like maybe 1 GB log file size, right? It just keeps writing here, writing here, writing here, right? And once we do this, once this log s1.log is full, you're saying that you don't have s2 again? Another
Yes.
log. Okay. Now, at some point this gets filled, right? Now it has to be written somewhere in the archives. Is that true?
Yeah.
Okay. Now at some point I have to copy this s1.log to some other archive files, right? Well, I mean, you can practically even do that here, but the only thing is, it's not even a recovery time.
Yeah, I mean, if you are looking like a log switch point of view, you will have a cleaner one just to copy S1 when you are working on S2. S1 is basically, it's like, is on back burner, right? So maybe that's what they are trying to do. Maybe when we are
No,
trying to do our,
no,
no,
no. Log switches are not the reason. I mean, a clean log is not a reason for having that many log files. um, there is. See, here is a philosophy. Generally, I mean, I'm just trying to do a reverse engineering, just brain not working. We generally say that have 3 to 4 log switches, uh, log switches a hour, log switches per hour. Too many log switches also is a performance concern, right? Too many log switches also performance concern. So we say that okay, 3 to 4 log switches. Generally, we say that okay, one log switch for every 15 minutes, just a standard, right? Not have too many log switches because log switch is end of the world. When I'm switching from s1.log to s2.log, right, it actually stops everything at the system during that maybe split second operation. Now that's where the point of why can't I have a very bigger log file. What if a crash happens? right? Yep, it's when a crash happens. Yeah, I'll check on that. I know that looks like a feasible option, um, but I just need to read a little more on crash recovery scenario. What happens when a crash happens? I have a full backup. I'll restore it or incremental. On top of it, the system just applies this s1.log. Right.
I don't know. I'm just thinking, could it be that, when you have so many small log files, like S1, once it gets full, it goes and it becomes the archive log, right?
That is true. That is true.
So, I mean, I think the reason could be that they're trying to like archive as much as possible in terms of any crash happens.
Yeah, that's even my thought. So because archives, we keep it in a multiple locations just to be on a safer side, right?
Mm-hmm.
So that's not the same case with log files, right?
Mm.
Yeah, but there are some databases which keeps multiple copies of the same log file at this level itself instead of archives. So, but only thing I can think of at this time, Vasusari, is just to be on a little more safer. So this s1.log is only one copy. What if this directory I lose? Let's say you are saying this is 1 GB, right? Writing this entire 1 GB, let's say, takes for me 3 hours. What if I lose this directory in middle, right? So instead of that, if I divide this 1 GB into, let's say, s1.log, which is, let's say, okay, 50 MB, which takes 9 minutes. After every 9 minutes, I do a log switch, right? So I'm safe till last 9 minutes. Even if something happens to this transactional logs directory, I have an archive copy somewhere. So other than this, I don't see a reason why we cannot have.
No, when it comes to the archive log, it's basically archive log you have to kick off, right? It is not an automated one.
It's
So when you are
automated.
doing automated means you have to schedule for every 5 minutes, 10 minutes, whatever that is, right?
No. So the way it happens in DB2 is the moment this log is full s1.log, the moment you switch to the s2.log, it can happen immediately or it's a matter of like 4-5 seconds little delay. This filled log file is moved to archive log location. So here is the flow, right? You have a log buffer, you have a user messing up something in memory. It just written into log buffer. From log buffer, it's written into transactional logs, incremental logs. From incremental logs, it will go to archive logs. So the switch between incremental to archive logs, especially in DB2, happens automatically. Yeah, from archive logs, it's up to us. Like if you want to move to some other location, or if you want to put it in a multiple locations, yeah, this guy can keep it in multiple locations. So let's say what I'm saying here is this log buffer is like 50 KB. I have S1, S2, S3. So this is an ever incremental one for archive logging mode. At any point, if any of the log file is full, they will be automatically moved into archive location. Here we have an option to give multiple archive logs location. Archive logs directory 1. I can give archive logs directory 2. So the same copy is moved to multiple location. So to help you understand, this process is automatic in DB2. The moment a log file is full, it will be moved into the archive log location.
So we never need to issue like a log
Backups? Yeah, same question.
No, no. You actually take log backups here at archive log location. So these online logs will be immediately moved to archive log locations. This is automatic.
Okay, so when we take, so let's take a step back. When we are going to do that, right? When I'm going to give my my level of confidence to the customer, say, hey, I'm taking all your log backups, right? That means I'm just copying this archive log file to a tape. Is that what I'm trying to do for the DB2? Other than that, we don't do anything.
Okay. The moment you have this archive log location itself, the backups, it's a first safer point. So this is so okay. Let's go back here. So log buffer, you have it in memory. The changes are written into transaction logs, which are on disk, right? So this is not that safer because it's only one location. It starts writing. From here, the moment the log file is full, you write it into archive. When I say you write it, system will take care of it, moving it to the archive log location.
One second, Ravi. Let's explain my question in a different way. Okay, so especially when we are dealing with banks and the critical data, we don't really assume that have the server exist or any file exist. Let's say we lost the entire thing. So when we are saying that we have 100%, we are taking, we are telling. I'll give a good example from the SQL Server point of view. So when I'm giving confidence to a customer saying that every 5 minutes your backup is secured, I'm putting in some tape or a different location, not just in the server or somewhere. So in that, I'm giving the level of confidence anytime when I say that specific time. So let's say every 5 minutes. So I can guarantee that 5 minutes, until that 5 minutes, you're all cleared. So let's say right now in EST time, it's 10:11. Right, until 10:11, if I take a backup now, it's guaranteed. But the question I'm a bit concerned is archive log is taking only when S1 is full, right? But it is not the active log itself. When you are running, the expectation is you have to be up to the mark. You see what I mean? That's where I'm trying to understand.
Okay, I see your point. In that case, you have no option other than switching the log file so that it comes to archive, then take it at the archive location. So when I say okay, we have two scenarios here. We have a scenario where the transaction logs are keep on getting incremented, right? And it is coming to archive. You just take archive level backup here, the backup at archive level. So just copy these files physically to tape or whatever we are talking. Okay, but we are talking about here 5 minutes where I don't have a log switch. Okay, so in that scenario, you can still go back to this switching the log file. When I switch the log file at that point before I'm taking the backup, let's say I'm still at S4. You do a log switch, then you will get S5 allocated here. Now S4 will come to this archive log location. Yeah, till that point, take a backup. Right.
Yeah, all I need to do at the time, if I really want to say at that given point of time I'm covered, I got to issue a log switch. Is that correct?
Yeah, till that point, till that exact point, if you want to take, for example, that same bank scenario. Yes.
Okay, got it. Thank you.
Right. So you can still copy this, I can copy the archive logs. I can still do it. These are just a physical log, physical files, right? But you can even ignore doing the what you call doing the log switch, but that's just to be on a safer side, right? Let me show you this. That's what I have it in the next slide. Just hold on. Right. So let me get into this database level configuration and show you these various parameters. Okay, so when I say DB2 list to DB directory, this is very interesting because different databases use it in a different way. When I say DB2 connect to utils, DB2 get DB config grep -I, I'm grepping for a word called log in a database configuration of utils. Now let's watch out this. Let me start with the first one, log buffer size. Right, this is in a memory buffer. The size is 2149 pages. So the log buffer size is 2149 pages. Okay. Now, whatever the directory you are seeing, this is a active log files location. So let me go back to the here. So this is what I showed you here. So let me put it at the bottom. What is the parameter for this? Log buffer size. Now, what is the log buffer size? This is the question we are answered. How many transaction logs allocated by default? So what is the transaction log path? This is the path. So this is where my transactional logs got allocated. So what is my current transaction log? This is the current transaction log S00003. Right? Now let me take you there. So this is another path. This is my archive log location. Okay. So the moment you have some value for this log arc method one other than off, which is a archive log location. Now let me take you to this directory. You see the log files which are in the form of S. This is from memory, the first point of directory. This is the big log file we are talking about here. This is how much is the size? KB. Yes, the 4 MB size. Okay. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So why it allocated 1, 2, 3, 6, 9, 12. There are 12 files allocated here. Why it allocated 12 files? Because the log primary is 13. I mean, it should allocate 13, but sometimes DB2 works in a lazy concept, right? You will see 13 log files here. 3, 5, 6, 7, 8, 9, 10, 11, 12. Even you don't see 13, don't worry. You know, the moment you come at 14, it automatically allocates 15, right? How many log files to allocate depends upon this log primary. So this is another important parameter here. Now let me show you that experiment of moving file, this S003 from here to here, right? Now let's go here and see what I have within this. What happened to S001 and 002, right? It should not start numbering from 3, right? Something happened to 1 and 2. Now let's go to this directory. I'll explain this directory. You see S001 and 2. These are in an archive log location. This is the location. So my current log is S003. This guy has these 3 logs. Right. Now, if we are talking about taking a point in time backup just to safeguard our banking applications, kind of an application, you know, go ahead and make sure you back up this archive directory, these 3 files, and this current log file, a simple copy command, CP command. Or if you want to be safer, you know, if you don't want to mess up copying something from these active logs, okay, from here, you simply do a log switch so that 3 comes here. Okay, and this becomes 4. then just take a backup of 0, 1, 2, 3 here. It's up to us how do we want to design. But in that scenario, it's a manual. You have to do a log switch if you are doing a log switch to bring it here to here. But the moment it is full, and when you move on to yes 004.log, right? So this will immediately be placed here. Again, like I said, DB2 is a little lazy. It might take 1 second, 2 seconds, 3 seconds, but it comes down there to the archive log location. But like I said,
One second.
Yeah, 1 second. Yeah, 1 second.
Yeah.
By the way, I can say here there is an archive log directory. You can give multiple archive log directories, right? I can have the same copy of multiple archive log directories. Yeah, go ahead, sir.
Yeah, it could be a funny question, but let's say you have in the primary, the log primary definition, when you said, does it apply to the archive also?
No, there is no restriction on archive how many log files we have. It's just our storage limit.
Okay. Because if that is the case, if I issue a log switch,
right?
You know what I mean. The next question, right? Okay.
There is no limit here. This is just plain storage. No. Okay.
One question, Ravi, here again.
Yes, for sure.
So we have, say, let's forget about the number. We say we have 15 log files in active, of which say the first 3 got full and they came to archive.
Right.
Okay. So at this point, say there's something has happened, some crash or anything of that kind. So we have only the 3 archive, 3 files in the archive, and maybe the 4th one is still active. And does that mean the remaining 4th and 4 onwards until 15 are still empty, or they are all filled at random?
They are empty. They are empty. Yeah, they are.
So at this point now.
Yeah.
Okay. So at this point we have 3 full in the archive.
Right.
The 4th one is still in active, still
right.
in halfway through kind of thing. So we back up the archive. How we back up the archive log files? What is